All right, hello people watching this video. This is the day 1 of Algebra 2 review. Make sure that you're writing down anything that you need on this packet, including formulas and all the stuff, but also at the same time, make sure you understand what you are writing down. I just told the class that this is not going to perform magic for you, so that like if you write stuff down, you can write down every single step and it's still not be able to figure it out on the test. So make sure that you are understanding what we are doing. We're going to start and work front to back. We're going to try to get hopefully maybe 20 questions done. At least 15 hopefully would be great. Starting with number 1. So we are in chapter 5. This is inverses and radical, which is the square roots. So inverses, but before we do that, they're going to have us do some operations and stuff. So they give us 2 functions. The first one's called f of x. The second one's g of x. What does this say? F minus g. So all we're doing is the f of x, which is 2x squared plus 4x minus 6, and we're doing minus 2x minus 2. That's all we're doing, is we're just subtracting them, right? Okay. We just got done doing this in our review. What's the trick here that you need to make sure you do? Distribute the negative. So this becomes minus 2x plus 2, right? And then this 2x squared plus 4x minus 6, that doesn't change at all. Then you have to combine like terms, right? So the highest power is 2x squared, and he doesn't go with anybody else, so he's just 2x squared. Okay, cross him off. I have 4x and I have negative 2x. So positive 2x if you add those together, and then negative 6 plus 2? Minus 4, that's it. Right? Not too bad. It's just using the notation. That just means subtract. Okay? Number 2, still the same functions, f and g, but what does this say right here? It's like f and then right next to g. What does that mean? Multiply. If you see 2 things right together, that means multiply. F times g. So I'm going to write it like this. 2x squared plus 4x minus 6 times 2x minus 2. Okay, I'm gonna multiply them like that, just the way that they are. Can you multiply in the other direction and do the 2x minus 2 first? Yeah, you can. That's fine. But I'm just going to do it the way that they did. So we're going to start with 2x squared, and we're going to multiply him by this 2x first, right? What's 2x squared times 2x? 4x cubed. Okay, then we're going to take that 2x squared and we're going to multiply by negative 2, right? That makes negative 4x squared. Okay, then I'm going to start with the 4x right here, and I'm going to multiply him by 2x. That makes plus 8x squared. Okay, then 4x times negative 2 minus 8x. Okay, then I start with the 6 minus 6 times 2, 12x. Negative 12x. And negative 6 times negative 2 is plus 12. Okay, almost done. I've got to combine like terms now. Okay, I can combine like terms. So I have x cubed. There's no other ones of those, so I'm just going to say 4x cubed. Cross him off. Okay, I do have two of the x squared parts, so I have negative 4 and positive 8. Plus 4x squared. Okay, minus 8x minus 12x. Minus 20x. And then plus 12. All done? Yep. That's it. Okay, good?
Can you show me the last question?
Are you done?
Hey, Carter, guess who's talking at breakfast? Michael and Diana.
Okay.
Oh, man. They
Yo.
eat lunch together?
Yo.
Who's Diane?
Golf meet.
All right, ready? This one's a little hard. We still have our 2 functions, but this one says this. Do you remember what this is?
Plug it in.
What's this little circle mean? What's that little circle? Compose. This is a composition. Compose. Okay, and when you compose, you stick one of them inside of the other. So a lot of people write, instead of putting that circle there, they'll go g parentheses f of x, and they'll write it with parentheses instead. That means the same thing. These are both the same, different notations for the same thing. So compose. All right. So we have our g function, we have our f function. Which one goes inside of the other one? The f. F is the one on the inside. That's going inside of g, right? Okay. So the g function is 2x minus 2. But we're taking f and we're putting it in to the g for x. We're plugging him in there, right? Okay. So I'm going to do 2 parentheses minus 2, right? And then we're going to put the f right there for the x, right? So 2x squared plus 4x minus 6. You see that? So it was 2x minus 2, and now I'm plugging the f of x inside there. Okay, now what? I'm not done yet. Distribute the what?
2.
The 2, so I can do this, okay? What's 2 times 2x squared?
4x squared.
4x squared plus
8x.
8x minus
12.
12. And then we still have
Minus
minus 2 on the end there, so if I combine like terms, 4x squared plus 8x minus 14. There we go. Okay. Now he's stuck inside of there. Good, good? Okay. Okay, now this is also kind of the same type of deal, but they're saying, this is composition again, but using parentheses. They're saying f composed of g of 2. What happens when we have a number there?
2 in the g function.
You plug 2 into the g function, right? And then whatever you get for that number, you're going to plug that number into the f function, right? Okay? You plug it in like inside out, like it goes backwards, okay? So I'm going to do g of 2 first. And if I plug 2 in for g, I'm plugging 2 in for that x. So 2 times 2 minus 2 is a lot of 2's. And the answer is
2.
2. Ha! That's a coincidence. So now, since g of 2 was 2, now I find f of 2, right? So I do f of 2 equals, okay, 2 times 2 squared plus 4 times 2 minus 6. Are we lost at all? Stop me if you are. Okay. All right, 2 squared is 4. 4 times 2 is 8 plus another 8 minus 6. 8 plus 8 minus 6 is
8 of 6. Oh.
10.
Right. That one was
Yep, yep. So 10. So the whole answer is 10. Not 2 and 10. Just 10, right? Just 10. Okay, now we get to the hard stuff. Was that easy so far? Kinda, maybe? Huh?
Wait.
Wait, this isn't R, then find the R.
Inverses? You know how to find the inverse?
That's a reciprocal.
Okay, so finding the inverse. There was 4 steps to finding the inverse. Do you remember what they were? 1, 2, 3, 4. Number 4, or 1, 2, 3, 4. This is our function, f of x equals 1/2 x plus 3. This is a linear function, right? So you start at 3, go up 1 over 2, just to get that in our brain, like we have a, you know that, okay? Find the inverse of him. All right, number 1, what do we do first? F of x gets renamed to y, right? We call him y now. And then what? What's that mean? X and y switch places with each other. Okay, so let's just do those first 2 steps. So we can call this guy y. I'm just going to call him y there, right? That's the first step. Step number 2, I switch the x and y out. So what will it look like?
X equals half y plus 3.
1/2 y plus 3. Okay? All right, now what do I do?
Oh, I'm on the wrong one.
Now I solve for y. I get the y back by itself again, right? But I have to undo the equation in order to solve for y, right? Okay? So if I'm trying to get this y by itself right here, this is the hardest part. Step 3 is the hardest part of all 4 steps, right? If I try to get that y by itself, what do you do first?
Plus, minus 3.
Minus the 3. Oop, minus 3, okay? What's it look like? X minus 3 equals 1/2 y. Okay, now, y is still not by itself, but we're close. How do I get rid of the 1/2?
2 times that.
So you can divide by a half, but the same thing as dividing by a half is multiplying by 2, right? And that cancels this out, and multiplying by 2. Now, the trick here is, I bet you a bunch of you are going to put 2x minus 3 and call it a day.
No,
And that's wrong.
minus 6.
It's 2x minus 6 because you've got to distribute the 2 through, right? Okay, 2x minus 6 is the inverse. And then what's step number 4?
Switch the x and y back.
The y goes back to
F of x.
f inverse of x, right? Hey, we just got done with
what?
trig functions. We just got done with trig functions where we have inverse cosine. That has that -1 symbol. Hey.
Wait,
Inverse cosine, inverse f of x.
Where's the answer?
Man, oh man,
Are
right
we
here.
done now?
So we're not done yet. We got to rewrite this guy. Okay, so instead of calling it y, I'm going to call it f inverse of x equals 2x minus 6. And that is what he is. Yeah?
I didn't get that inverse stuff.
You didn't get what?
That inverse stuff.
Okay, we're going to do another one. So hopefully you'll get it now. All right, next one, number 6. This is also an inverse one. Okay, do you want me to rewrite the steps, or are we good if I just draw an arrow? Arrow, those steps. Okay, finding the inverse. Except this time they call it g of x,
So
but that doesn't do anything. We're still going to rename it as y. Okay, step 2. Switch x and y. X equals 3y over 2 minus
12
12. Okay, now step 3 is the hardest step. We're going to undo it. So we're going to do what?
plus 12.
Plus 12. We're going to add the 12 first. Right? We're solving for y. We're trying to get y by itself. Right? So we add the 12 over, add the 12. So x plus 12 equals
3y over
3y over 2.
2 times by 2.
Yeah, let's times 2. Multiply by 2, multiply by 2. Okay, but when I do that,
2x plus 24.
2x plus 24 equals
3y.
3y. Okay, I'll wait just a second. We're not quite done yet. Ouch. Okay, last step is
Divide by 3.
divide by 3. Okay, and when we divide by 3, we divide everything by 3. Everything by 3. So, y equals 2/3 x plus 8. 24 divided by 3 is 8. Oh, and actually, we're going to call it g inverse of x equals 2/3 x plus 8. Okay? That's what my final answer looks like. Oof.
Put inverse sign there.
What?
Why?
Because that's what it is. This is the original g of x. The inverse is going to be the other one.
How did we find the inverse?
You undo it. You switch the x and the y, and then you solve for y.
Wait, so like we're gonna say,
You switch the x and the y, and you solve for y. And that's the result that you get is the inverse. Okay, these two equations like undo one another, right? Like one undoes the other.
Is the x
wait.
part always the
Let me see the
reciprocal?
answer.
Is the what?
The x part always reciprocal?
Yes, I believe so.
That's cool.
Yep. Good? Yeah, good? Okay, number 7. We have a graph over here, and we have to graph this thing. And this is the cubic root. So the parent function, if we write out the parent function is y equals the cubic root of x, right? And then we've got all the other numbers and such in there, and we've got to figure out what they do. But we've got y equals the cubic root of x, yeah? What does the cubic root of x look like? No. Kinda, but on its side. It looks like this. That's what the square root looks like.
Yeah. But when you cube it, you also get negative.
Cubic root goes negative also because you can take the cubic root of a negative, right? That's what the cubic root looks like. Like that's what it looks like.
Just draw that.
Okay, that's what this looks like. Now I have to graph this one.
Oh, well, these up, down,
'Kay.
over.
All right, so negative. What's the negative do?
Flip it.
Flips it.
Plus the x
Okay, flips it. What does the 4 do to it?
To
to
the
the
right.
right.
To the right 4. Negative actually means to the right when it's underneath of the bar. The negative means to the right. What's the plus 2 do?
Up to.
Up to. Okay, so this point right here is called the point of inflection. I'm going to move him to the right 4 and up 2. So instead of being here, he's going to go to the right 4 and up 2. So there's his dot. Okay? And then he's flipped. So he's going to go this direction and this direction. Okay?
Why is the graph
To the right 4, up 2, and then flipped. Why is the graph what?
like terrible?
Mm.
I can have those dumb things where you have to like find the reciprocal?
No.
Okay.
Not of this. Okay, but we do have to find domain and range.
All real numbers.
Okay, domain is the x's. So going left and right. Will he go left forever?
Yep.
Will he go right forever?
Yup.
Does he have any problems in the middle?
Nope.
No. So all reals for the domain. Range is the y's. Y's go up and down. Does he go up forever?
Yep.
Yes, slightly. Like he'll go up slightly forever. Will he go down slightly forever?
Yep.
Yes. So all reals.
Yup.
Crazy. Yep. Yep. Okay. Good. All right. Number 8. We just got in solving these. Yay.
Thank goodness.
Thank goodness. Okay. All right. What are we going to do to solve for x? X is right here. We got to undo the stuff.
-3.
Okay, let's subtract the 3. -3 minus 3. Okay, so I have negative. Don't forget that negative out in front. X minus 11 equals 3. Okay, then what?
Times -1.
Yeah, I'm gonna divide by -1. It doesn't matter. It's the same thing. Okay, so to get rid of that negative, we divide by -1 or times -1. Doesn't matter, right? Divide -1. Okay, so the square root of x minus 11 equals, what's 3 divided by -1? -3. Okay, now what?
Like square it.
Now we square it, right? Okay, the square and the square root cancel. So we have x minus 11 equals
9.
positive 9, and then
+11.
add the 11.
X equals 20.
X equals 20. Yeah, very nice. Boom, first page, done.
The inverse ones, I hate them.
Well, then you better study those.
How many questions?
Okay, number 9. There's another one of these. Woo-hoo! Number 9. We've got a cubic root. What are you going to do first?
+6.
Plus 6. Plus 6 plus 6. So, 3 and the cubic root of 3x minus 1 equals
6.
6. Then,
Divide by 3.
divide this 3 over. So I have the cubic root of 3x plus 1 or minus 1 equals 2. Okay, now what?
Cube it.
Now we cube it. We take it to the third power now, right? What's 2 times 2 times 2? 3 times.
8.
So I have 3x minus 1 equals 8. Oh man, this is going to come out nice.
+1.
Add the 1. 3x equals
3.
9. And divide by 3. X is
3.
3. Okay. Now you can always check your answer by plugging these back in if you would like. Right? Make sense? Good?
Yeah.
All right. Good, good. Beautiful. Okay, let's go to number 10. All right, now we're getting into log functions.
Oh, I remember.
Yeah, log functions. So number 10 is an exponential function where we're talking about like compound interest and stuff, okay? So the equation, this equation right here is going to give us the stuff that we need, but let's dissect this. Let's talk about what is A of t, like what does this thing mean?
Start. Your end.
That's your ending, that's your after amount, okay? Like what it's worth after a certain period of time. What is this A? That's the starting amount. We call this P most of the time. I think we started using P, but this is the starting amount. Okay? 1 plus or minus, when like plus and minus, like why do they have plus and minus?
Is that what you have like a range?
Kinda really. Plus and minus. It just depends on whether you're increasing it in value, is gonna make it a plus, or decreasing it in value is going to make it a minus, okay? So we have to choose. And then R is the rate as a decimal, right? And T is time, usually in years, okay? All right, so we're going to start plopping stuff in. Use the equation to solve the following. A car that is $20,000, that goes in for P or A, right? That's what they call it, like little a. That's the starting amount. Depreciates. What's that mean? Minus at a rate of 15% per year. So the rate is 0.15. Find the value. So what are we finding? Find what?
The end value.
Capital A. That's what we're trying to find. That's what we don't know. Of the car after 5 years, which is
Time.
T. Holy cow, we got lots of stuff going on here. Okay.
No, this is easy.
Okay, so we're finding A. Okay, the price is 20,000. You saying that's high or low?
No, like the after amount.
Oh, the after amount? Yeah. 1, is it plus or minus? Minus 0.15 to the fifth power. Okay, it would not hurt for you to practice typing this into your calculator right now, just to make sure you get the correct answer.
Too late.
If it's depreciating in value, I know my number should be something less than 20,000, right? Otherwise I did it wrong. And it probably shouldn't be a negative value because this equation is set up to not go negatives. Otherwise you would owe money for trading a car in. That would be like silly, right? You know, like it wouldn't be, anyway. What you got? 8,874.10. 8,874.10.
Or
11 11 cents.
Yeah. That's what I got anyway. That's what I got.
Yeah, very nice. Okay, so that's just plugging stuff in. Okay.
What are you doing on it?
He's trying to find his calculator.
Yes.
Oh, I like logs.
Uh-huh. All right, these next two. You're like, give me tons of these, right? Okay. This is a log function and an exponential function. How do you read this? Like, what is that read?
Log base 8, 64.
Log base 8 of 64 equals 2. Log base 8 of 64 equals 2. So if I want to make this into an exponential function, I make it into an exponential function. You should be experts at this. It goes, what?
X, EX, or whatever the.
No, there's no e's. You just use the numbers that you have given. 8, 64, and 2.
Oh, the 64 goes to the little
The
number.
X equals
The first number stays in the same spot. The second two numbers switch places. So 8 to the
Second.
second power equals 64. That's it. They just want you to rewrite it as an exponential function, right?
Oh.
Should make sense, right? Is 8 squared 64? Yeah? Okay. Now they're wanting us to do the opposite for the next one, for number 12. Okay, so they want us to make it a log function. So we're going to start with log. What's the base of the log?
4.
4, right? The base of the log is 4. Okay? Of
64.
64 equals
3.
3. That's how you make it a log function. Right? You're just switching back and forth. Give us a ton of those because those are the easy ones, right? Okay? Good? All right, now it's the hard part. 13. Solve this. Okay? Is this a log or an exponential function? Exponential. This is an exponential function. Okay. All right, so what are the bases?
3 and 9.
3 and 9. 3 and 9. What can I do with this? What? Nah, kind of close. We're going to rewrite the 9. You remember doing this? 9 is the same thing as 3 squared,
Oh.
right? 9 is the same thing as 3 squared. So we've got 3 squared and then 3x plus 7 equals 3 to the 4x power. Okay? So we're just rewriting. The only thing I swapped out is the 9 became 3 squared. Yeah? Okay, now the 3's cancel, right?
Oh, yeah.
So I have 4x equals, and what's on the right side?
6x plus 14.
6x plus 14. Okay, then what?
Take like
Solve for x, right? Let's
x equals negative 14.
subtract. I'm going to subtract 6x. It's fine.
Minus 7.
Okay, 4x minus 6x is negative 2x equals 14. And then
X equals 9.
divide by negative 2. So x equals negative 7. Beautiful. Look at that. Okay. All right. Next, express this as a single log. How many logs do we have right now?
2.
1, 2. We have 2 logs. What's in between them?
A minus.
Minus. What does minus mean?
Subtract.
Nope. Minus means
Multiply.
divide. Minus means divide. Plus means
Multiply. Oh.
multiply, right? When we're doing logs, that means you divide the end pieces or you multiply the end pieces, right? So if I want to combine this as a single log, I will have log base
3.
3 of
9.
81 divided by 9. I'll take and divide 81 and 9 because we're subtracting. That means divide, right? 81 divided by 9, right?
9.
Okay? But that really means log base 3 of 81 divided by 9 is 9, right? And then it says and simplify.
Oh,
So we have to actually find the answer.
Okay,
So I say equals,
0.
no,
2.
equals x. All right? I say equals x. And then let's make this an exponential function. So this would say 3 to the x equals 9. What does x have to be? 2. 3 squared is 9. Yeah?
Or you can do that.
No. Because if we don't write it out, I'll count it wrong.
She's not cool. She doesn't understand.
I do understand. That's the problem.
How did you get 2?
How did I get 2? Do you see where we got it? 3 to the x equals 9? No? Do you see how we got it? 3 log base 3 of 9? Are we confused? Start back over? Okay. So these two pieces separated have minus, right? Okay. But when we put them together as one log, minus means divide. So I get rid of the logs and I only have one log. But I take 81 divided by 9. And they become here, right? Yeah? So that's 9. So we have log base 3 of 9. But then they say simplify that. So they want us to actually find what is log base 3 of 9. So we say, okay, let's set it equal to x, right? But then if we switch it around and make it an exponential function, we say 3 to the x power equals 9, right? Okay, then what does x have to be? 3 to the second power is 9, right? Like 3 squared is 9. That's what x would have to be. That make sense? Yeah? Make sense? Kinda? Kinda? Circle it and we can go over another one. Okay? All right, let's go to the next one. Change log base 6 of 31 to a base of 10. And then solve. Okay?
Oh, I like these things.
So, to a base of 10. Right now it's a base of 6. And most calculators think in base 10.
Push the button twice.
No.
3 times.
What? What are you talking about? No. 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 I want to change it to a base of 10 without cheating. You're cheating. You're cheating.
Cheating.
You're cheating. I want you to change it to a base of 10. So I want to change this to be like log base 10 of something. Right? Change it to a base of 10.
Log 6
Oh, 30.
31 equals x.
Log base 10. Log base 10 of
31.
31 over log base 10 of 6. That's it. This is how you change it to a base 10. You make them both log base 10s, but you put 31 on top and 6 on bottom. Okay, so then on your calculator, all you need to do is take log 31 divided by log 6. Log 31, close parentheses, divided by log 6. 1.9165.
1.
Okay, you have to have both of those pieces, otherwise I'll count it wrong.
What?
1.9165.
The big number always on top.
What?
The big number's always on top.
The base number always goes to the basement.
Okay.
Yeah. Right, like the number in large print goes on the top. It doesn't necessarily mean the larger number because your base could be a big number and a small number. So anyway. Okay, good? All right. Now another way to think about this is like if we do this like we did just a minute ago, where we have log base 6 of 31 equals x, this would say 6 to what power gives me 31, right? Well, I know that 6 to the first power is 6. 6 to the second power is 36. 31 fits in between there. So I know that my decimal number has to be a number between 1 and 2, right? Pretty close to 2. 1.9165. Sounds good, right? So you can kind of see, does that seem reasonable, right? Okay. All right, 16. Holy cow. All right. Let's identify the equal sign. So I'm going to put a line there. But I have 3 logs.
This is easy.
How is it easy? What are you going to do?
They all have
So,
6s.
these don't need to
They all
be
have log
logs.
base 6s.
Yeah.
But can I do this? Shoom, shoom, shoom.
Yeah.
Can I do that?
Only 2 of them.
You can only do 1 on each side, right? Okay? So I can't go shoom, shoom, shoom.
But you can go
Ooh, but I can do these 2 put together. How do I put those 2 together? What's in between them?
plus, so multiply.
Plus, so multiply. So what will they look like?
10x
Log base
equals
6 of 10.
40.
Log base 6 of 10 times x, right? If I put them together, multiply, equals
X equals 4.
log base 6 of 40, yeah? And then I can go shoom shoom, right? 10x equals 40 and divide by 10. So x equals 4. Do you know what answer I get most of the time? What answer do I get most of the time?
10.
No.
40.
What do people put as the answer most of the time?
They don't cross off the 40.
Log base 6 of 10 plus log base 6 of blank equals log base 6 of 40. What do you think I get as an answer most of the time?
Log base 6 of 4.
No.
Yeah,
30.
How do you
Right?
get 40?
How?
30? Because people look at that plus sign and they're like, oh, 10 plus 30 equals 40. But plus actually means multiply, right? So it's 10 times 4 equals 40, not 10 plus 30 equals 40. Does that make sense? Okay?
Oh.
Right?
I didn't even
But I probably get about half of the people that do 30 instead of 4 because they add instead of multiply. Okay, so be careful with that. All right? Good?
open.
All right, we got one more on this page. And we've got like 7 minutes left. All right, so there are only 2 variation. This is variation functions. There's 2 of them that I will give to you. And I'll write them both down here. So I could say direct variation, or I could say inverse or indirect. Those mean the same thing. Okay, inverse or indirect. So direct variation, if 2 things are varying directly, like if I say y varies directly as x, what does that look like?
Oh,
Wow.
X over.
Y equals, if they're varying directly, you're multiplying, but what does it look like? Y equals, we have to use k. What?
K times X.
K times x. Y equals k times x. That's direct variation. Okay? What does indirect or inverse variation look like?
Is that K over Y?
K over x. Y equals k over x. So on the test, I don't remember. I might do inverse rather than direct. I don't remember. So make sure that you're prepared for both of those. So write both of those functions down, direct or indirect. There you go. Okay. All right. First thing says, so we know we're doing y equals kx because we're doing direct variation. Okay. And y equals 18 when x is 3. What does that help me find?
K.
Okay, so y equals 18
K 6.
when x is 3. So that means k is 6. I believe it. If we divide by 3, k equals 6. Okay, now I have y equals 6x, right? Because we know that k is 6 now. And it says, okay, now find y if x is 5 instead. So find y when x is 5.
30.
Y is 30. And that's my final answer. But you got to go through all the steps to do it. You have to solve for the k first, your constant, so that you can solve for the next piece. Make sense? Yeah? Okay, good. All right. How much further do you want to go?
Let's do,
No more, please.
Oh, I mean, we did 17. We got, what, 40 problems? So we are almost halfway.
we're at kind of a good stopping point.
I know, we are at kind of a good stopping point, actually, because the next ones are going to be like really ugly.
Let's just stop.
Should we just stop? Okay?
Are
All
we
right.
gonna be able to finish this tomorrow?
No, we're going to finish on Friday.
We're not going to be here tomorrow.
So you're going to have to watch the video that I record
I'm already.
for
Stop the
tomorrow.
video.
Okay? Goodbye, people in the video.